So today we are going to be learning how to use correlation matrix to define different parameters in a set of data. Correlation matrix is used to show the relation between variables contained in a dataset. So as you can see, this is the correlation heatmap. As you can see, this is the correlation heatmap that we have been able to generate. As you can see, this place is empty. There is no figure here. Reason being that these parameters were constant in the table, so they does not produce any correlation either with themselves or with other parameters. So WC against WC, you can see it is null, which means it is 0. In our next class, we shall teach you how you can actually, if you want to fill these empty spaces with 0, you can actually fill it with 0 to lay more emphasis. So, and you can see this is the granite content. The granite content, we have 0.58. This 0.58 means that granite content relates to comprehensive strength at the correlation coefficient of 0.58. So 0.00 means that this is the relation between the granite content and then the curing days. Now what does this mean? It means that the comprehensive strength now is the most important variable here, which depends on other variables. So I will use the column of comprehensive strength to round off this explanation. Okay, so comprehensive strength, which is 1.0 against 1.0, because it's comprehensive strength against comprehensive strength, so it is just 1. Then 0.75 against against the curing days shows that the curing days has great impact on the comprehensive strength. That is to show that as the curing days increases, the comprehensive strength also increases. Then granite content also shows a good correlation between the comprehensive strength, meaning that as the granite content is increasing, the comprehensive strength will also be increasing. And as the recycled rubber aggregates are increasing, the comprehensive strength will be decreasing at this rate of correlation coefficient. So that is just it. So you can actually explain the table and then with this correlation coefficient, and it gives you a clue of the relation between a particular variable and another variable, or a variable with the other variable. And if you come here, it is 0. Comprehensive strength against sand is 0 because sand was constant throughout the curing days. So cement is also constant throughout the table. WC was also constant throughout the table. So that is it. So let's move forward. And this is a table of 36 rows. In our last class, we were able to load this table into a data frame. So for the benefit of that, you can consult our last class, which is attached on the same playlist with the current lecture, so that you can see how to load this into a data frame. Because we are moving forward, we are not going to reload it into the data frame again today. So thank you as you follow us, and don't forget to subscribe. This is where we stopped in our last class. This is we were able to load this, the data I showed you earlier. We were able to load it into a data frame, and we defined the data frame as df. So that was where we stopped. So today we are working on producing a correlation heatmap. So the first thing is to import the necessary libraries. Pandas is already there, which helped us to create the data frame. We are not touching pandas, so but we are going to import 2 new libraries that will help us today, and they are our popular library, matplotlib, pyplot as PLT, and we know what matplotlib pyplot does now. It helps us to do the plotting of the graph. And then we're also going to import Seaborn today. So in our class, I think this is the first day we are importing Seaborn. So this Seaborn is built on top of matplotlib and provides a high-level interface for creating informative and attractive statistical graphics. And as you can see, we have denoted it as a CNS. So we go down because we have already loaded the data, so we don't need to do that again. So we go down immediately and continue. So we put our description, instrument, compute, and display correlation matrix. Compute and display correlation matrix. Okay, so call underscore matrix is equals to df dot score. We open our parentheses. So this line uses the call method of the data frame to calculate the correlation matrix. The correlation matrix shows the relationship between the columns in the dataset, just like we have said earlier. The columns are the parameters the content of the dataset. Okay, so we are going to move to define the fixed size, the size of the correlation matrix. That is what we want to define now, which is the normal thing we do. Fixed size is equals to 10 6. I know what this means, where 10 is the width in inches and 6 is the height also in inches. So I think we are good to go. So we continue. SNS.heatmap. SNS.heatmap. No. .heatmap. We open our parentheses for underscore is matrix, then a note is equals to true. CMap is equals to coulomb inside the quote. Then we have FMT is equals to inside quote we have 2F. Then we have dot 2F here. Then we have our comma, and then the line width now. The line width is equals to 0.5. Okay, so now what does this do? Why? Let's go back. So the SNS.heatmap is where the CPON is used to create the heatmap. Then the call matrix displays the correlation values on the heatmap. Then and not true says the color scheme. Coulomb is a common choice with blue for negative correlations, red for positive correlations. And then the FMT is equals to 2F, formats the correlation values to 2 decimal places. It formats the values to 2 decimal places. And then line width is equals to 0.5, which is the last as the line between the cells of the heatmap for better readability. So now we are going to proceed by plotting the title of our heatmap, then plt.title. We have double quote correlation matrix. Correlation, we can say correlation matrix or correlation heatmap, any one you want to use, but let me use heatmap here. Okay, so this is the title we want our figure to be. So we have plt.show. So what does this do? It displays the correlation matrix. So you can see it is as easy as anything. We are done. This is where we started, and then this is where we have come. So let's actually display the correlation matrix by running the code by pressing Shift Enter. So the code has started run. Okay, so the code has run, and this is what you are seeing. There's a mistake at line 58. Okay, so this is why you have to always be careful, and that is this line, the line of SNS. So firstly, this should be capital T, and then at the end here I use O instead of 0. So that is where that was the error it talked about in the error message. So it was supposed to be 0.5. So now I've corrected it. You can see invalid syntax because it does not understand O. Now we press Shift Enter. So it has produced the results. So you can see the heatmap here.